My name is Marian Shoemaker, and this is exercise 8, and we are looking at predictive modeling with classification and regression trees within SAS Viya. So exercise 8.1 is talking about the confusion matrix. So we're going to be using the data in figure 8.1 to build this matrix, which is the Titanic data. So as you can see, I already put this in to SAS Viya. The roles being that the response is survived, and then the predictors are basically all of the other variables that were available to be clicked. So as you can see, we have the decision tree, variable of importance, survive versus perish, and the confusion matrix. So we're going to specifically just look into that to start. So we're going to expand it and look under confusion matrix. So as you can see here, this is basically talking about what people predicted would happen and what actually happened. You can see sort of the percentage of accuracy. So you can see that the highest percentage is when people were predicted to perish, and then they actually perished, and that was about 87%, and then the lowest was when they were predicted to survive but actually perished, and that was at about 12.75%. So going out of this, we are going to focus on this decision tree right here. So we are going to again maximize the VO, looking back on it, and we're going to look at the assessment statistics, and we can basically see we are asked, you can see right here, the specificity, sensitivity, accuracy, and F1 score of the decision tree. So that was calculated through SAS Viya. So we're going to look and see that the F1 score is about 0.76. And then that's really all we see that we want to see within this set of data. So then we're going to go over to ROC, and we can see the sensitivity and the specificity scores. So sensitivity and specificity both start off at 1, but you can see they slowly all decline. Both decline, sorry. Specificity ending up to end at 0, and sensitivity ending up at 0.02. And then I believe the last one, we're looking at accuracy. So this can be seen in the confusion matrix. So the percentage, that's how accurate the predictions were to what actually happened within this data set given. So now we are going to look at exercise 8.2, which is decision tree modeling for modeling of employee attrition data. So looking at exercise 8.2, I've already completed it within the SAS Viya software. So we are going to first maximize this to see the data, and we're going to go to node rules, and we can see that overtime, monthly income, total working years, age, and job role were sort of the ones that were talked about. So then going out of here, the next question was, what interpretation do you make of the model with regard to the predictors? So we're going into here. This is looking at overtime to do with total working years. So right here you can see total working years is about 8.39%. That says yes, overtime does have an emphasis on total working years. And then going down to job role, you can sort of see the yes/no answers in these bottom two bullets for all of them. So going to see what the relation is, and the relationship between the node and then the subparts of that. We're then going to look at this confusion matrix over here, looking at basically the accuracy of it all. So we are saying no and no right here. It was about 95.86% correct. We're looking at it was observed. It was observed to be no, but it actually happened. About 4.14%. Yes was about 48%, and then yes, no was around 52%. So then we're going to look at this KS score right here. So we want it to be around 50%. I'm going to take out education and standard hours since there's not much in it and see if that helps get it back to around 0.5, which is what the desired number is. So we can add in some over here to see if that'll change it, which that actually did not. So I'm gonna take these three out again. Actually, I'm going to take out performance rating this time to see if that helps. See if employee number will help. So I really can't tell a difference, or I can't get it to around 0.5, so I would have to go back in and try to see if I could get it to that desired area.